Hello guys, and welcome to this new Python tutorial. Today we are going to talk about data structures in Python and why are data structures very important in Python as in any other programming language. First of all, we start by the definition. Data structure is a way of collecting, organizing, and storing data in a way that we can access and perform operations on this data efficiently. As we are dealing with data science, data analysis, big data, data has to be organized and it has to be in specific memories locations and in specific, for example, lists, dictionaries, sets, depending on your programs and depending on the tasks and the problems that you are resolving. This data needs to have a form that allows you to understand it rapidly and to work with it efficiently. We have two types of data structures in Python. We have the inbuilt data structures, which are built inside our programs and in Python. And we have also the user-defined data structures. Data structures that you are going to define in your program and you are going to implement these functions or classes depending on your problems. For the inbuilt, we have lists, tuples, dictionaries, and sets. User-defined data structures, we have tree, graph, stack, linked list, and queue. Inbuilt data structures can be mutable or immutable. Mutable means that you can modify it. You can add, you can insert, you can remove, you can delete, depending on what you are looking for and what are using these data structures for. For the mutable, we have lists, dictionaries, and sets. Immutable data structures means that they cannot be modified. And we have only one type, which is called tuples. A list is defined as an ordered collection of items. It is the most used among Python data structures. It is changeable, which means that we can add, we can remove, and we can modify it during our programming task. It allows duplicates, and lists can be nested, which means that we can have a list inside another list. Okay, so the items inside a list can be also lists. A tuple is defined as an ordered collection of items, as a list, but it cannot be modified. Once you define a tuple, it will stay as it is in all your process of programming. And tuples are preferred over the lists when the user does not want the data to be modified. Dictionaries are used to store data values in key, comma, value pairs. It is a collection which is ordered and they are changeable, but they do not allow duplicates. As we have said, lists allow duplicates in your program, but it is not the case for the dictionaries. A set is defined as a unique collection of unique elements that do not follow a specific order, which means that inside a set, for example, we cannot find two elements that are the same. For example, in a list, you can have, for example, the element number 1 is letter E, the second is letter E, the third one is letter E. But inside a set, you can only have one letter. For example, E or I or T. So sets allow you to have unique elements, which means that you cannot have a lot of elements that are the same. For the user-defined data structures, we start by a linked list, which is a linear structure that is represented by a collection of nodes, and each node is linked to the other node by using a pointer. Linked lists are built in Python using classes. So object-oriented programming will allow you to build this kind of data structures, which is very powerful in very specific cases. A stack is also a linear structure that allows data to be inserted and removed from the same end. As you can see from this image, the last element that is added to the list is the first element that is going to be out, which means that last in, first out. We have also the queue, which is a linear structure as a stack, but the only difference here is that the first element that gets in is the first element that gets out. Okay, so it allows insertion of elements from one end and deletion from the other end. We have also trees, which are very useful and are applied in, for example, machine learning. You can apply binary trees in a lot of examples using classes and object-oriented programming. A tree is a nonlinear but a hierarchical data structure. The topmost node is known as a root node. Each node contains some data, and data can be of any type. Finally, we have the graph. A graph is a common data structure that consists of a finite set of nodes or vertices and a set of edges connecting them. So this is all for this video. I hope that you have learned new things. Thanks for watching and see you in the next one.